Dear children, today we will derive mirror formula. To derive mirror formula, here I have drawn three diagrams. It is a concave mirror producing real image. It is a concave mirror producing virtual image, and it is a convex mirror producing virtual image. Now you see this figure. You see it is the concave mirror. Here I have taken all the mirrors are of small aperture. So now it is the concave mirror. It is the principal axis. You see it is an object placed beyond center of curvature. It is one ray, incident ray, parallel to the principal axis. After reflection, it goes along KQ, passing through the focus. Another incident ray, here it is AP, passes along PS. And you see these two reflected rays meet each other at the point A dash. So here A dash, you can say it is the image point of A. You see this is the rays coming from A, these two incident rays. Now they are reflected rays meet each other at A dash. So A dash is the image point of A. Similarly, if you take a point at here, if the incident rays are coming from this point, then you will find the image point will be at here. Similarly, for this object point, the image point will be here. So in this way, for this object, you will get the image is A dash B dash. Here A dash B dash is the real and inverted image. So now come to this figure. Now why it is called as real image? Already told, real image, if the reflected rays actually meet each other to produce an image, then the image is called as real image. If the reflected rays after reflection from the mirror, if they diverge from each other to produce or to get the image, if they are produced backward, then the image is virtual image. So now come to this figure. You see it is the concave mirror. Here I have placed the object between pole and focus, and you see, and you know, for concave mirror, when the object is placed between pole and focus, then the image is virtual image. You see here, it is the incident ray. The same naming I have taken. The parallel incident ray to the principal axis I have named here, that is AK. Here also it is AK. After reflection, it goes along KQ through F. Here also you see. Similarly, another incident ray AP. After reflection, you see it goes along PS. The naming is reflected ray naming is PS. Here also I have named that is PS. Now you see the two reflected rays KQ and PS, they diverge from each other. So they will not meet each other at a point. So to get the image point, you have to produce backward. When they are produced backward, they meet each other at the point A dash. So now this point is the image point of this point A. Similarly, the image point of this object point will be this one, and for this object point, the image point will be this one, and for this P, the image point will be B dash. Then what is your conclusion? A dash B dash is the virtual image of the object AB, and you see here the image is erect. So you remember, whenever you will get real image, the image is inverted. Whenever you will get virtual image, then the image is erect. So now virtual, erect and magnified image is formed. So now come to this figure. It is the convex mirror. You know the convex mirror always produce virtual, erect and diminished image. So you see here, it is the object AP. It is the incident ray. You know, already told, the parallel incident ray, you name it as AK, it is reflected along KQ, and another incident ray AP, that another incident ray AP that is reflected along PS. When these two reflected rays produce backward, then they will meet each other at the point A dash. Now A dash B dash is the virtual and erect image, and you know, as it is parallel to the principal axis and the reflected ray is KQ and it appears to diverge from the focus. So now come to this figure. You see the two triangles A dash B dash P and ABP are similar or not. Let us verify it. You see, it is perpendicular, it is also perpendicular. Here we have taken these two triangles, triangle A dash B dash P and triangle ABP. And this angle is equal to this angle. Why? Because angle of incidence is equal to angle of reflection. So in two triangles, if two angles are equal, then definitely the third angle will be equal. That means these two triangles are similar. If the two triangles are similar, then the ratio of their corresponding sides are equal. That means A dash B dash by AP is equal to PB dash by PB. Here I have written. Similarly, go for another two triangles A dash B dash F and KPF. It is A dash B dash F and it is KPF. And already told that we have taken this aperture is very small. That means K is very close to P. When K is very close to P, then KP is almost a straight line. So now you can consider KPF is a triangle. So now come to these two triangles A dash B dash F and KPF. It is perpendicular. It is also perpendicular. These two angles are opposite to each other. Means they are also equal. Definitely the third angle will be equal. That means these two triangles are similar. So the ratio of their corresponding sides are equal. A dash B dash by KP is equal to B dash F by PF. As KP is almost a straight line, so KP is equal to AP. In place of KP, you can write AP. So it is A dash B dash by AP. In place of KP, write AP. So your equation becomes A dash B dash by AP, your B dash F by PF. So now you compare equation 1 and 2. You see LHS are equal. So definitely RHS will be equal. That means PB dash by PB is your B dash F by PF. That is your equation number 3. So writing up to equation number 3 is same for all the cases. Then this case also you can verify. Then how A dash B dash P and ABP are similar? Let us verify it. It is perpendicular. It is also perpendicular. You see, it is angle of incidence, it is angle of reflection. So these two angles are equal. And you see this angle and this angle, they are vertically opposite. So this angle is equal to this angle. That means this angle is equal to this angle. So in these two triangles, you see this angle is equal to this angle and this angle is equal to this angle. Means two angles are equal. So definitely the third angle will be equal. So they are similar. So you can write A dash B dash by B is equal to PB dash by PB. Similarly, A dash B dash F and KPF are similar. How? Because it is perpendicular, it is also perpendicular. And you see this angle is common. So now definitely the third angle will be equal. So they are similar to each other. So you can write A dash B dash by Kp equal B dash A by Pf, and since aperture is very small, so Kp is almost equal to AB. So you got A dash B dash by AB is equal to B dash A by Pf. Now comparing these two equations, you will get this. Pb dash by Pb is equal to B dash F by Pf. Similarly, you can verify for this. Now you see ABP and A dash B dash P are similar. Why? Because this angle and this angle, they are perpendiculars. Definitely, it is the angle of incidence, it is the angle of reflection. These two are equal and these two angles are opposite. So this equal to this, so this angle equal to this. So definitely, the third angle will be equal. So these two triangles ABP and A dash B dash P are similar. So you can write A dash B dash by AB is equal to PB dash by PB. And these two triangles A dash B dash F and KPF are similar. How? You see A dash B dash F and KPF, it is perpendicular, it is also perpendicular, and this angle is equal to common angle. So definitely third angle will be equal. So what is your conclusion? These two triangles are similar. So you will get this. So equation number up to 3 is same for all the three cases. So come to the first case. From figure 1, let it be figure 1, it's figure 2, and it is figure 3. From figure 1, you see what is B dash F. B dash F is equal to PB dash minus PF. So you can write PB dash by PP is equal to B dash F. In place of B dash F, you can write PB dash minus PF by PF. Equation number 4, and already told left measurements are negative and right measurements are positive. You see PB dash, that is the left of pole. So here PB dash is, here A dash B dash is the image, so it is minus B. Image distance you will take P, and it is left of P, it is minus B. Similarly PP, that is object distance, that is minus U. And PF, it is the focus, so it is focal length, it is the left of P, so it is minus F. So now you put all these values in this equation 4. What you will get? Minus B by minus U is equal to minus P minus F minus F divided by minus F. This equal to V by U minus V plus F by minus F. Now you cross multiply minus VF minus UV then plus UF. So now you take these two RHS and these two LHS. It is UV, it is VF plus UF. Now you divide UVF on both sides, or UV by UVF, VF by UVF plus UF by UVF. You will get it is 1 by F, it is 1 by U, and it is 1 by V. So here you will get 1 by U plus 1 by V is equal to 1 by F. It is the mirror formula. Equation number 5. Similarly, also you can find for this figure. So from this figure, all I told up to equation 3, that is same for all these figures. So from this figure, from figure 2, PB dash by PP, you see here what is P dash F. It is PB dash plus PF. So in place of P dash F, you write PP dash plus PF divided by PF. Now tell me what is PB dash. It is, you see, virtual image. So imagination to the right of the pole, you take the Cartesian convention, it is plus V by minus U, that is V, and you see PF, that is minus F, because it is left measurement, and divided by minus F. So you got for concave mirror, you have verified in both the cases the focal length is negative. So you remember, for concave mirror, the focal length is negative, or it is minus BF, it is minus UV and plus UF, or UV, it is VF plus UF. When you divide it by UVF, you will get the same equation, that is one by F is equal to 1 by U plus 1 by V. So it is the mirror equation, the same you got for this, and also will verify for figure 3 for convex mirror, whether that is same or different mirror formula you get. Let us verify it. Now from figure 3, that is for convex mirror, you see what is B dash F. That is PF minus PP dash, that is PP dash by PP, and B dash F, that is PF minus PP dash by PF, using equation 3. So now what is PB dash? You see PB dash right of the pole, it is plus V, and PP left of the pole, it is minus U, and PF right of the pole, it is plus F, and PP dash, it is plus V by plus F. So here one conclusion you got, for convex mirror, as the focus is right of the pole, so focal length is positive. So you remember, for concave mirror you will take focal length negative, and for convex mirror you will take focal length positive. Now cross multiply VF minus UF plus UV, or VF plus UF is equal to UV. Now you divide UVF on both sides, what you will get, that is 1 by U plus 1 by V is equal to 1 by F. So the mirror formula 1 by U plus 1 by V plus is equal to 1 by F, that is same for that is both concave mirror and convex mirror. The mirror formula remains same, that is 1 by u plus 1 by v is equal to 1 by f. Now come to magnification. Magnification you remember it is the ratio of height of the image to the height of the object. That is m is equal to hi by ho. Hi is the height of the image and ho is the height of the object. So now come to equation number 1. We have written that is a dash b dash by fb, that is pb dash by pb. This equation we have. Now for real image, what is the magnification? For real image, what is the magnification formula? You see, it is the real image. A dash b dash, it is inverted. So it is, you use this formula, a dash b dash by b is equal to pb dash by pb. What is a dash b dash? It is minus hi. And what is a b? It is erect object, that is plus ho. And what is pb dash? That is left measurement, that is minus b. And what is pb? That is minus u. So you will get here hi by ho minus hi by ho v by u, or hi by ho that equal to minus v by u. What is hi by ho? That is magnification. Therefore m is equal to minus v by u. For real image, the formula for magnification is minus v by u. So this magnification we are studying, that is linear magnification. That is image distance divided by object distance. So now for virtual image, use this formula, a dash b dash by b is equal to pb dash by pb. Now virtual means, you see, it is the erect image. That means a dash b dash is plus hi. Plus hi. What is a b? That is already erect. That is plus ho. What is pb dash? Virtual means it is the right measurement, right of the pole. You see both the cases. That is plus b. And what is pb? You see in both the cases, that is minus u. So you will get hi by ho equal to minus v by u, or m is equal to minus v by u. Now what is your conclusion? So conclusion is that whatever the mirror, that may be concave mirror, that may be convex mirror, whatever the nature of the image, that may be virtual image, that may be real image, the formula, mirror formula remains same. That is 1 by u plus 1 by v is equal to 1 by f, and also the formula for magnification remains same. That is m is equal to minus v by u. So now you see, if the image is real or real image, the formula remains same. What is the sign of the real image? What is the sign of magnification in case of real image? So now come to a real image. You see image distance, that is negative, the object distance also negative. That means m is equal to minus of v is negative divided by u also negative. That means it is negative. So magnification sign for real image it is negative, but formula remains same. So now virtual image m is equal to, you see that minus v by u. You see image distance positive and object distance negative, minus, that is positive by negative, that equal to positive. So you got the sign of the magnification for virtual image is positive and sign of the magnification for real image it is negative. So still you are in doubt, then by solving one or two numericals then you will be clarified. So let us take one example. Suppose you have a concave mirror which has focal length 20 centimeter. It produces a real image of magnification 2. Real image of magnification 2. So you find what is the object distance and what is the image distance. Repeating the question, that a concave mirror of focal length 20 centimeter produces a real image of magnification 2. Magnification 2. Find the object distance and image distance. So to solve the numerical, you remember the mirror formula, that is 1 by u plus 1 by v is equal to 1 by f. Magnification formula is m is equal to minus v by u, and focal length negative for concave mirror and positive for convex mirror. So this convention you have to take, and you will take left measurements, that is negative, right measurements are